Hi, good evening. This is Sangeetha from ECE department, SNS College of Engineering, Coimbatore. So today we are going to discuss about the 8051 microcontroller. So first we will see the main features of 8051. So it is a 8-bit CPU with registers A and B. So 8-bit CPU means the data bus with is 8-bit, and so the next one is the address bus with is 16-bit address bus, that is so the address bus determines the total memory capacity of the system, and it has 8-bit program status word, and it has oscillator and clock circuits. So the main the internal RAM capacity is 128 bytes, and it has internal ROM, that is 4 kilobytes, and it has a 16-bit program counter and data pointer. So there are two 16-bit timer counter circuits, and there are four ports, four input output ports. So all the ports are 8-bit wide, and three internal interrupts and two external interrupts, and there is a control register. So first we will see the architecture diagram. So here there are four ports, and on the top of the architecture, port 0 and port 7, and it is connected with a latch, and ROM and RAM is available, and accumulator B register is available. It is connected with a ALU through temporary registers. So and the ALU output of the ALU is connected with a PSW, and SFR registers is available. And in the left side of the diagram, there is a timing and control circuit, and there is a oscillator circuit, and bottom of the architecture, port 1 and port 3 is connected, and the right side of the registers DPTR and program counter, stack pointer are available. So this is the architecture diagram of 8051. So A and B register, that is CPU register. So 8051 contains 34 general purpose or working registers. So two of these registers are A and B. A means accumulator. So the immediate result is stored in the accumulator register for next operation. So the B register is a register just for multiplication and division operation, which requires more register spaces for the product of multiplication and the quotient, and to store the quotient and remainder for the division. So the B register is mainly used during the multiplication and division operation. So the accumulator is a special purpose register because all the data to be sent to ALU is received through accumulator, and all the results are stored after the execution in the accumulator. So that is why it is called special purpose register. And the next one is program status word. In the name itself it says that is status of the ALU, that is the status of the result. Okay, so there are that is, it is otherwise called flag register. It is a flag registers. So it is an 8-bit register. So the first bit is parity and user flag. Overflow, OV means overflow. RS0 and RS1 is used to select a register bank, and user flag F0 is a user flag 0, and carry, auxiliary carry. So the PSW contain the math flags, user program flags F0, and the register selection bits, that is RS0 and RS1. The math flag includes carry, auxiliary carry, and overflow parity. So this is the oscillator circuit. Generally crystal oscillator is used for the computers. So the crystal oscillator is connected and the capacitor is also used to connect the crystal oscillator. The oscillator circuit usually runs around 12 megahertz. The crystal generates 12 impulses in 1 second. So the machine cycle is a minimum amount time must taken by simplest machine instruction. So the 8051 machine cycle consists 12 crystal pulses. and the first 6 crystal pulses, that is clock pulses, is used to fetch the opcode, and the second 6 pulses are used to perform the operation and the operands in the ALU. So this gives an effective machine cycle rate 1 MAPS. MAPS means million instruction per second. So next we will see the memory of 8051. So there are two types of memory, that is data memory and program memory. So the data memory is otherwise called as RAM and program memory is otherwise called as ROM. So the internal capacity of the data memory is 128 bytes, and additionally we can connect 64 kilobytes of the memory externally, and the total internal ROM capacity is 4 kilobytes, and additionally we can collect we can connect externally 64 kilobytes of ROM. So this is the memory configuration of 8051 system. So internal RAM structure, that is 128 byte internal RAM and SFR. So the 128 bytes is divided into 4 register banks: bank 0, bank 1, bank 2 and bank 3. So all the register names in the bank are R0, R1, R2, R3, R4, R5, R6, or 7. So to differentiate which the microprocessor fetches in which bank is known by reading the PSW register, that is program status word register, the pins RS0 and RS1. If RS0 and RS1 both are 0, that is the register can be accessed in the bank 0. So if it is 0 and 1, that is bank 1 is selected. So if it is 1 0, the bank 2 is selected, and if both pins are that is both bits are 1 in RS1 and RS0, bank 3 can be accessed. So there are 4 banks. And the next one is data pointer. Data pointer is a 16-bit register. It is used to access the external memory address. So it is a even though it is a 16-bit register, it can be used it can be accessed or used to 8-bit register, that is DPL and DPH. And this is the stack pointer. So stack is a portion of RAM. Stack pointer is used to hold the memory address of the top of the stack. So as I already said, stack is a portion of RAM and it works on the principle of last in first out. So there are two instructions used, push and pop. Push is used to write the data into the stack, and pop instruction is used to read the data from the stack. This is the stack and stack pointer. So this is the architecture of 8051. Thank you.